Hello students, welcome back to the next module of our chapter called electromagnetic induction. Now students, in the previous modules we have already covered the concept of self-induction, right? Now students, in this particular module again we'll be starting with a very interesting concept called as mutual induction, right? So let us start with the concept of mutual induction. Now students, in order to understand the concept we need to consider two coils, primary coil and secondary coil in this particular case, right? So let's say I'm having primary coil B which is connected to a cell which is having EMF E and key K, and all these stuff is connected in series, right? See the diagram carefully. Here I am having primary coil, it is connected in series with the cell having EMF E and key K, right? Now along with the primary coil I'll be needing one more coil which is named as secondary coil and represented by symbol S, and it is connected to a very sensitive galvanometer. So this is our secondary coil over here, right? It is connected to a very sensitive galvanometer. And why do we need this galvanometer? So as to detect the value of induced current in the secondary coil. And these two coils are placed very close to each other, right? Now I'm pushing this particular coil, secondary coil, towards the primary coil, right? And they are kept very close to each other. Now let us take this circuit ahead. Right, now see primary side, I can say key is open, right? And when key is open, what can you say about the current in the primary coil? I can say current in primary coil, that is IP, will be equal to 0. And as current is 0, I can say flux in the primary coil, that is phi P, will also be equal to 0. Now as flux of primary is 0, I can say there is no flux which is associated with the secondary coil, and thus I can say flux which is associated with the secondary coil, that is phi S, it is equal to 0. Now you see carefully, there is no flux which is associated with the secondary, or I can say there will not be any change in the value of flux over here, and as there is no change in the value of flux, there will not be any EMF induced in this particular situation, right? Or I can say as no change in flux is there, no EMF is induced, right? Now let us move further. Now when key is closed, now see the primary side. Now I'll be closing the key, see carefully. Here we have closed the key. Now once we have closed the key, what will happen in that particular circuit? I can say current will increase, and I can say current will increase from 0 to its maximum value, right? So that means IP is changing from 0 to IP max. Now as current is increasing from 0 to maximum value, the flux of primary will also increase from 0 to its maximum value, or it will change from phi P equal to 0 to phi P is equal to phi P max. Now as flux of primary is increasing, the flux which is associated with the secondary coil will also increase, right? And it will increase from its 0 to its maximum value, or I can say phi S is equal to 0 to phi S is equal to phi S max, right? Now let us move further. Now see carefully, flux which is associated with the secondary coil is increasing, or I can say there is change in the value of flux with respect to time, and this change in value of flux with respect to time will lead to production of induced current in the secondary coil, and because of this induced current, this particular galvanometer will show deflection, right? Now see the diagram carefully. As key is closed, current will increase, and as current is increasing, see magnetic flux is increasing, right? And as flux is changing, this galvanometer is showing deflection, and again it is coming back to 0. Why it is coming back to 0? Because once the flux reached its maximum value, or I can say once flux phi S has reached its maximum value, there is no change in the value of flux, and as there is no change in the value of flux, there is no induced current, and hence the deflection in galvanometer again becomes 0, right? Now let us summarize this. Now what has happened over here? I can say there is a change in current in the primary coil, right? And because of the change in current in the primary coil, there is a change in flux in the primary coil. Now because of the change in flux in the primary coil, I can say there is a change in flux which is associated with the secondary coil, and because of this change in flux, what is induced? EMF is induced in the secondary coil. Now see carefully, EMF is induced in the secondary coil, right? So I can write EMF is induced in the secondary coil. Why is it getting induced? Because of the change in the current in the primary coil. So I can write EMF is induced in the secondary coil due to the change in current in the primary coil, and this particular phenomena is basically referred as mutual induction, right? So what is mutual induction? Mutual induction is nothing but a phenomena in which EMF is induced in the neighboring coil due to the change in current in the primary coil, right? So let us define it. So what is mutual induction? Mutual induction is that particular phenomena in which current is induced in the secondary coil due to the change in current in the primary coil. Now students, see carefully. This induced EMF is produced only when there is change in current. So there is no EMF induced when the current in the primary is constant or it is equal to 0, right? And in this particular situation, there will not be any deflection in the galvanometer which is connected in the secondary coil, right? Now let us move further. Let us define it. So mutual induction is the phenomena of production of induced EMF in one coil due to the change in current in the neighboring coil. So students, in this particular module, we have covered a very interesting concept called as mutual induction, in which EMF is getting induced in the neighboring coil due to the change in current in the primary coil, right? So students, for the mathematical part of this particular concept, I'll see you in the next module. Till then, keep learning.